Hello, welcome to 6-4. As I told you in class, we are going to be talking about how do we solve special systems. We're going to break this up into two parts, and today's vocab words are inconsistent system and consistent system. So an inconsistent system is a solution or a system that has no solutions. And a consistent system is a system that has at least one solution. So it can have one solution or it could have many solutions to be considered consistent. So it's kind of the same idea. Before we had identity and contradiction with no solution and many solutions. Kind of the same idea, except for now with systems we call them inconsistent and consistent. So what we're going to do first of all is just kind of look at what do these special systems look like when we're solving them, because just like with identities and contradictions, we're not going to know that it is a special system until we start to solve it. So I'm just going to show you this system here, and I'm going to show you how it looks using each of the different methods, so that no matter what method you're using, you'll be able to recognize if it's a special system. So if I have this system here and I want to solve it by graphing, the first thing that we have to do, remember, is put them in slope-intercept form. So this would be y equals x plus 3, and the other one's already in slope-intercept form. So the first line would start at -4, and it has a slope of 1, so it's going to go up 1 over 1. And again, remember, when we solve by graphing, we have to make sure that we have really straight lines, so that we can tell where our lines intersect. Okay, so there's my first line. Now my second line is going to start at 3. And it also has a slope of 1. So, if I draw that line, now you might notice here that these lines are parallel. Now how do we know that? Well, we can see it on the graph, and we can see that they have the same slope. And if you'll remember that we learned in chapter 5 that lines with the same slope are parallel. So these lines are never going to intersect. So remember that the solution to the system is where the lines intersect, and these never do. So this system has no solution. Okay, so if we're solving by graphing and we come up with parallel lines, we know that it means no solution. Now here's the same system. Now let's say that we want to solve it using substitution. Well, y is already solved for, so I'm going to take this x minus 4, I'm going to put it in for the y. So I'd have -x plus x minus 4 equals 3. You can see here -x plus x is 0, so my x's get canceled out here. So then all I have left is -4 equals 3. And just like before, I ask, is this a true or a false statement? Well, it's false. -4 does not equal 3. So, just like with identities and contradictions, we know that this system has no solution. Now finally, let's say that we had the same system and we were wanting to solve it by elimination. Well, first of all, we'd have to make sure that our x's and y's are lined up. So I'm going to move this x back over here to the other side, so I would have -x plus y equals 4. And then down below here, I would have -x plus y equals 3. Now, since I have variables with the same coefficient, I'm going to subtract. So -1x minus -1x is 0x, and y minus y is 0y. So over here I just have 0, and 4 minus 3 is 1. So my variables have canceled out, and I have a statement here, and it happens to be a false statement, so I have no solution. Now all of those are the same exact system. I just wanted to show you what it looks like with the different methods. So with graphing, when I graph it, I'm going to get parallel lines. When I'm using substitution, I'm going to end up with a false statement. Same with elimination. My variables are both going to cancel out, and I end up with a false statement, so I get no solution. So that's what no solution systems look like. Now let's look at the opposite here. If I have two linear equations and they have the same exact graph, that means that there are many solutions, because every point on the line is a solution to both equations. So again, let's take a look here at a system, and I want to show you what it looks like when we have many solutions. And again, I'm going to show you what it looks like under each method so that you can get an idea. So here I need to solve this bottom one for y. Now the easiest thing to do here would probably just be to move the y to the other side. So then I get 3x plus 2 equals y. And here I get y equals 3x plus 2. Now you can kind of see that something's a little fishy here, because we have the exact same equations. So when I go to graph these things, okay, the first one starts at 2 and has a slope of 3 over 1. And now so does the other one, right? It starts at 2 and has a slope of 3 over 1. So they end up being the exact same line. When that happens, I know that there are many solutions. Okay. Now let's look again at the same system, but let's use substitution and see what happens. This one's already solved for y. So I'm going to take it, I'm going to plug it in for y down here. So I'd have 3x minus 3x plus 2 equals 0. Well, remember this is negative 1, so I got to distribute it. So I'd have 3x minus 3x minus 2 plus 2 equals 0. Now notice here that the 3x's cancel each other out and the 2's cancel each other out, so I have 0 equals 0. So once again my variables have canceled, but now I have a true statement, and when I have a true statement I know that it's many solutions. Okay. And finally, let's look once again at the same system, but let's use elimination. So in order to use elimination, I have to have x and y in the same spots. So to do a little work here, let's move this 3x over. So I have negative 3x plus y equals 2. And let's move this 2 over to the other side. So I'd have 3x minus y equals negative 2. Now, when I add these together, negative 3 plus 3 is 0, y plus negative y is 0, 2 and negative 2 is 0. So, everything cancels out, and when that happens I end up with a true statement, 0 equals 0. So then I have, again, many solutions. So those are kind of the special types of systems that you'll run into. And as I said, I just wanted to show you what it looks like in each method, because you'll be using a variety of methods. So just to summarize again, if it's no solutions, the lines are going to be parallel, or in the other two methods you're going to end up with no variables and a false statement. If it's many solutions, your lines are going to be the exact same line, or in the other two methods your variables are going to cancel out and you're going to end up with a true statement. Okay? Now tomorrow we will talk about how do we classify these sort of systems, and we'll kind of work on just how to name them based on what they look like. So if you have any questions, let me know, and I will see you tomorrow.